For those who have racked their brains before finding this video, be rest assured, you are not the only one. But you will be surprised at how simple the solution actually is. Two circles intersect at points B and C. Through B, two line segments ABD and PBQ are drawn to intersect the circles at A, D, P and Q respectively. Prove that angle ACP is equal to angle QCD. So let's solve. Welcome to Math-o-tropism. First step is understanding what is given and identifying the concept. Since this sum is in the exercise which deals with cyclic quadrilaterals, our first intention will be to join AP, BC, DQ and try to find the relation in the cyclic quadrilateral, and that is where we are making the mistake. So we'll read it again slowly and try to understand what exactly is needed. So given is two circles intersecting at points B and C, and through B we are drawing two line segments ABD and PBQ, and all the points are lying on the circle. So now we have to prove that angle ACP is equal to angle QCD. Now first let us start with what we have to prove. Now we have to prove the angles are equal. First let us know what are those angles. When we see the angle ACP, what is that angle? It is the angle subtended by the segment AP, and similarly angle QCD is the angle subtended by the segment DQ. Now, can we see any relationship between theorems and what is already given? So we know that when we talk about a segment, we have a theorem where angles in the same segment or equal can come, because we have another angle ABP also formed by the segment AP, and similarly we have DQ forming another angle QBD in the same segment. When we look into the other two angles which we have now found, that is the angle ABP and QBD, we can see that both are equal because they are vertically opposite angles formed by the lines AD and PQ. So since they are vertically opposite angles, they are equal, and since these two angles are also equal to the angles subtended by the segment individually, it means that these two angles, that is ACP and DCQ, will also be equal. So this is how we are going to prove. So forming equations and solving the sum, given are two circles intersecting and at B and C, line segments AD and PQ passing through B, intersecting the circles at AD, P and Q. To prove angle ACP is equal to angle QCD. Solution is angle ACP is equal to angle ABP considering the segment AP, and we know that angles in the same segment are equal. Similarly, angle QCD and angle QBD are also equal. When we see angle ABP will be equal to angle QBD because both are vertically opposite angles. So from 1, 2 and 3, angle ACP is equal to angle ABP from the first equation, which is equal to angle QBD from the third equation, and which is ultimately equal to angle QCD from the second equation. As a result, angle ACP is equal to angle QCD. Thus